की ज्याच्यामध्ये
येस सर.
की ज्याच्यामध्ये आपण सिव्हिल इंजिनिअरिंग सुद्धा पुढच्या लेवलला नाही तर आयटी वगैरे काय कानामागून आली आणि तिखट झाली असं झालंय ते सगळं यार. बाकी सगळे डिपार्टमेंट्स आपली पोरं पण खेचून घेऊन जातात आणि जास्त पगारही देतात. सगळ्यात चॅलेंज आहे आपल्या कन्स्ट्रक्शन आणि सिव्हिल इंजिनिअरिंगला.
Good morning, sir.
गुड मॉर्निंग सर.
Sorry for the technical glitch, sir.
नाही नाही, नो चॅलेंज सर, नो चॅलेंज.
Now I requestfully hand over this session after the reading of brief CV of Mr. Chetan Raikar, sir. I request him to kindly begin the expert session. Thank you so much, sir.
Sure. Thank you. Namaskar and good morning, everyone.
Good morning,
Happy
sir.
to connect. Happy to connect on second. I think we connected on Tuesday, and again we are connecting on Saturday. Today I am speaking from home. Karnamala, we have a fourth Saturday holiday. So if there is a little glitch, I will call one of my family members to help me in IT. I am not good at IT. So let me try and share my presentation. Are you all able to see this?
Yes sir. Visible
And
sir.
Yes, sir.
yeah, I'm trying to. Yes, now the bigger one.
Yes sir.
Great.
Yes,
So
sir.
I'll start straight away. The subject today is very interesting and complicated also. Retrofitting and rehabilitation techniques for enhancing infrastructure resilience. It's a very niche kind of a subject on which, if I have to share my thought processes with you for about 90 minutes. So as I said last time also, I'll make it to about 85 minutes, and last 5 or 10 minutes we can keep for question answers. So please share your questions with me, even if they are related to the earlier lecture or any other technicalities in repairs restoration. We can share those questions here if permitted by the host. Now, definitions of all R's. R is one is retrofitting. Retrofitting is where uh, you have to upgrade a structure to the current codal provisions. See, try and understand. If a structure is constructed in 1980 and the earthquake codes has been revised thrice since then, or a structure is constructed in 1995, IS 456 has been revised in 2000 since then. So if I have to upgrade, if a client says that I must have a structure which is compliant of the current codal provisions, then I need to carry out retrofitting on the structure. See, now a question should come to everyone's mind is the structure that was constructed in accordance to the previous standards, is it unsafe? No, it cannot be called unsafe, but the codal provisions are improving every decade, every 2 decades, and things like that. So if a particular client says for some internal purposes or for insurance purposes or for some international insurance purposes, I want my structure to be compliant of the current codal provisions, you need to upgrade the structure. You need to strengthen several structural members. Sometimes even walls have to be strengthened. I'm not talking about load bearing. Even in RCC frame, sometimes the walls are required to be strengthened. You remove certain brick walls and convert them into RCC walls, so that two structural components can be connected together through RCC and they behave much better. I'll have a little case study on that. Then is re-strengthening. The process of increasing load resistance capacity of a structure or portion. Simply if I am converting a residential building into a commercial building, if all the beams and columns and footings are safe, but the slabs are unsafe, then I can only strengthen the slab, increasing the load resistance capacity or load carrying capacity. So that can be called as re-strengthening. Rehabilitation, the process of repairing the structure to meet desired useful condition. Upgradation of structure to meet present need, mostly for abandoned structures. See, there are several structures which become very, very bad because of an earthquake, after a cyclone, after a blast, after a fire damage, and so many other calamities. And a structure is abandoned for many years. There are several structures which are abandoned after a war. They are required to be internationally. This is very common. After the Second World War, all the warehouses that were used for storage of grenades and other ammunitions were converted into residential buildings. So that's where is a typical case of rehabilitation. Then restoration, the process of re-establishing the materials, form and appearance of the structure. Re-establishing, in the sense, whatever existed, we re-establish it to the either original condition or the desired condition. That can be called restoration. And repairs, the process of replacement of damaged part components of a structure with new material or with new material of similar size, quality and number. Now, what's the difference between the repairs and restoration? In the restoration, you can upgrade it to the original condition also. This was the original condition. The structure has come down a bit in strength, in load carrying capacity, but this condition also is acceptable to me currently. So I am restoring a structure, I am repairing a structure to this condition and restoring to the original condition. That's the difference. In retrofitting, I am taking it to the next higher level of load carrying capability as per the current codal provisions. Rehabilitation is where I have abandoned the structure and rehabilitate. Habitation is where you go and live. So rehabilitation is more used in structures which have been abandoned, and re-strengthening is where I have a structure, I need to re-strengthen it for additional load of a certain nature which may or may not be again compliant of the codal provisions. See, the provisions in code are much more stringent than the load carrying capacity itself. You know, the detailing that is given in earthquake codes today, the reinforcement detailing, is very complicated. No structure constructed prior to that code will be compliant of these new codal provisions because the reinforcement has not been provided. How do you provide a reinforcement now? It's not easy. It's not simple. It's very, very difficult. So I believe you have understood the difference between these 5 R's. And I learned a new material, new subject, a new word, resilience. So I was going through the dictionary literally. The resilience means the ability to bounce back from difficult experiences. So this is a definition of resilience as far as a human being is concerned. How can a structure bounce back on its own from difficult experiences? The only difference between a human and a structure is we have a self-healing property. We have a self-healing ability. Our body heals on its own. Even if, see, if you get a common cold, even if you don't do anything, it will get okay in 3 days, 4 days time. But we want to be all right in 12 hours, 24 hours. So we go for medication. Otherwise, our human body has an ability to bounce back from difficult experiences. Whereas a structure cannot bounce back on its own. We as doctors have to help the structure bounce back from difficult. What can be the difficult experiences a structure will have? These are, the effects and the causes. Let's see this. These are the difficult experiences the structure has. We will go to the previous slide after this. Corrosion. Corrosion is a difficult experience. It's an ongoing experience a structure has. Fire. Fire can be once in a lifetime for a structure, can be twice for an industrial structure. But fire is not something which is a regular feature. Corrosion is an ongoing process. Salt attack or marine attack. The difference between salt attack and marine attack is salt is where a salt is formed in an industry where salt is produced. Not only NaCl, but there are so many other salts which are corrosive in nature that are produced. So industry producing that particular, like magnesium sulfate. You have magnesium chloride. So there is an industry which is making magnesium chloride, and that the structures which are loading the reactors that are used for production of the salts, the structure has corrosion. So that is a salt attack, and marine attack is the coastal area. Indian code says about 50 kilometers there is a process, but we do have corrosion in other cities also. Why do we have corrosion in other cities? One is because of heavy pollution, and second is there is a big trend of converting agricultural lands into construction. Agricultural lands have been the earth has been polluted with nitrates and so many other salts for higher yield in agriculture. That so earth is rich in salt. So the subsoil water that we take out from a bore and use in construction is extremely bad for concrete. There are so many cases of multi-story towers which have been demolished in less than 5 years in Gurgaon or Gurugram now we call it. So there are so many cases. So it's either it is used by the developer innocently or it is used by the developer knowingly. In either cases, that's a salt attack on a structure, and in less than 5 years, the structures have come for demolition. Earthquake is another challenge that civil engineers have. Our country is prone to earthquakes. So we do have earthquakes every day, which are not noticeable but recorded. We do have major earthquakes once in few years, and I pray that no human being dies in an earthquake because of collapse of a structure. Because collapse of a structure is a civil engineering failure. If it is an earthquake, see, a structure can be disabled after an earthquake and needs a strengthening before it's put to reuse. But collapse of a structure and human beings dying is a failure of civil engineering. That's what I personally believe. Blast damage. Blast can be thanks to our neighboring country. We have blasts because of terrorist attacks. We have blasts because of industrial reactors blasting or industrial pressure vessels blasting. We have unfortunate blasts in our residences also. Cylinders which are becoming more and more and more uncommon now, gas cylinders, but in second tier cities, third tier cities, it's still very common. So those cylinders can blast. And we have cyclone like tsunami and so many other these things. So this is where these are the difficult experiences a structure can have. Now let's look at the next slide. Causes and damages in a structure. Effects, the leakage. What is the cause? Inadequate water tightness of concrete or plaster, or improper joint details of two dissimilar material. You know, a crack between a brick masonry and RCC has become very common, and unfortunately it is accepted. I really don't understand why it is accepted, but it is accepted by civil engineers. The crack तो पड़ेगा ही उसमें. उसको हम लोग क्या करते हैं? We put a chicken mesh and we plaster so the crack, but the crack is there inside. It's just an escape route. So the joint between two dissimilar materials should not crack. Special provisions have to be taken while constructing a brickwork, and those cracks will not form. So inadequate water tightness of concrete. Concrete is porous, honeycombed, and not watertight. And external plaster is again not watertight. These are the reasons why we have leakage. We also have leakages in toilets where the plumbing has not been done properly or not maintained properly, and so many other things. But we have water tightness of the waterproofing on the terrace. We have challenges of chhajja waterproofing. We will see some of these in this presentation today. Settlement is over-designed SBC. Either the SBC has been wrongly designed. If it was 30 and it has been designed as 40 or 50, and the structure is constructed taking into consideration that over-designed SBC or under-designed foundations. So the foundations have been wrongly designed by a structural engineer. I had a case recently near Sangli where the foundations were under-designed and the structure is having severe cracking because of the partial and complete settlement of the structure. Deflections, again, under-designed structural member or overloading. Like similar to settlement, we have deflection, that is under-designed. A structural member, individual beam or a slab has been under-designed or overloading. See, third third case also can be here. While I am talking, I just felt the slab has been not cast properly. See, a designer has given the slab thickness of say 125 mm. What people do is they don't design. They in the center, because on both sides or rather four sides, depending on whether it's a one way or two way, we have bent up reinforcement. So at the joint of beam and slab, you definitely get a thickness of 125 if the cover is maintained properly. But in the center, you can get a saucer-like effect and the thickness reduces. And that also can be a reason for deflection of slabs. Wear and tear is inadequate abrasion resistance. See, inadequate abrasion resistance also is relative, because even steel has a abrasion resistance to a certain extent. But if you go to a local train ticket vendor in Bombay, even the brass plate, which is there for 50 years, is abraded with human touch. So if a plate also can abrade, any structure can abrade. The weirs are abrade, they abrade with water force. The jetties abrade because of excessive usage. So it is, any structure has to abrade after a certain time. But if it abrades in early years of its service life, then it's a wrongly designed structure. Spalling or disintegration can be because of corrosion, because of fire, because of impact or an accident. Honeycombing and delamination is nothing but poor construction and lesser or inadequate quality control and quality assurance. Plastering, people nowadays, engineers are not able to train a kadia in plastering. It's other way around. A kadia trains an engineer, unfortunately on site, and kadia does what is convenient to him. He doesn't do what is good or what we call as good engineering practices. So plastering is a very serious business, and people must study plastering. Let me, if time permits, I'll talk for a couple of minutes on plastering also in this presentation. Scaling. So scaling is peeling out layer by layer. So plaster can scale because of leakage, salt attack, stone because of weathering. Over a period of time, the stone scales out. Structural steel, that is corrosion, is again a scaling. It goes from outermost layer to inner layer. Corrosion also travels from outermost layer of steel to the inner layers. That's where you see. And cracking can again be structural and non-structural. I think we saw it in my previous lecture on Tuesday, so I'll not waste. Here are a few slides, couple of slides, 3-4 slides you may find as repeated from the previous, because in the previous lecture also I covered a bit on repair techniques. Today we'll see repair techniques in greater details. And there can be a cracking in material, age related. Wood can crack, steel can crack, stone can crack, brick masonry can crack as a component. Brick masonry as a material can crack, and concrete can crack. This is again a huge slide where I have tried and compiled all the possible cracks that one sees in concrete. I have broadly divided the cracks in before hardening and after hardening. So you will get about each type of the crack in the books on concrete technology. So I will not elaborate on this because of paucity of time, but I will request that once this slide is shared with you, whoever in the faculty is teaching concrete technology, explain every type of crack to the students. One of my challenges when your students come to me as a professional, after graduation or diploma, one of my challenges is the boys are unaware of the material concrete. They only know one property of concrete, that is strength, and they are able to talk little more confidently on strength. They have very little confidence while talking on the cracking in concrete. During concreting session, that is before hardening and after hardening. So I would request you all to train, and I can request the hosts to even share my mail address with any of the faculty members, and they are most welcome to share their challenges, and I can share more data, whatever is available with me, even post this lecture series or this FDP. Maintenance, repairs, and retrofitting methods for masonry structures. Let's get straight to the subject now. There are several techniques. So I will be now talking on maintenance, repairs, and retrofitting methods for masonry structures, that is load bearing structures, and concrete structure, that is RCC. So we have some techniques are similar, so some slides may even repeat, but some techniques are completely different. So we will see both. There are several techniques, several in restoring load bearing masonry, whether it's a stone load bearing masonry or a brick load bearing masonry, or now we have concrete blocks load bearing masonry also. So any kind of wall construction created with any material, cracking can be a little different depending on the type of material, but majorly, if it is an earthquake, the cracking is similar. If there is a fire, the cracking is different. So re-waterproofing, replastering, grouting, micro grouting or grouting with cement, grouting with polymer epoxy, graniting and shotcreting, raking and pointing. These are basically a few techniques. We will also see the techniques of stitching. These have been identified for member strengthening, and these have been identified for material strengthening. So you can see the difference. So here we are strengthening the material, and here we are strengthening the member. I would slightly differ with my own slide. Graniting is also member strengthening. We will see how. We'll be seeing a photograph and explaining each of these in the next these things. This is where typically a sloping roof in a heritage building can be restored or conserved. You can see that in this slide, you can see that this is the original wood and this is the eroded wood that has been replaced. So you replace only what is the eroded wood in a heritage building or in any material. Why replace something that is good? Then it's not repairs, then it is reconstruction. So we should try and repair only what is bad and not touch something that is good. So I say in Hindi in on my sites that जो अच्छा है उसे तोड़ना नहीं और जो बुरा है उसे छोड़ना नहीं should be the principle in repairing or re-strengthening or anything. So let's see, the first photo is where you replace it with new wood. You can see a difference in wood. So this is new wood, this is old wood. Then you can also see these are the original battens which have been the purlins which have been removed. On the top, once the whole planking is relaid with tongue and groove or whichever technique of joinery that you are using, on a sloping roof, polymerized bitumen based membrane over the entire sloping roof. See, what you see here is vertical battens. I will go to the previous slide. What you see here, you do not see the vertical battens. है ना? Why do this is what I started about 30 years back, providing the vertical battens. Why? Because if you have Mangalore tiles, on above these battens, you have purlins. Purlins for a Mangalore tile, all of you must know that they are at a distance of 300 mm. So if I put, like if you see in the previous batten, the purlins have been laid directly on the top of planks. So if a Mangalore tile cracks, the rainwater goes and is stopped at every purlin junction. So rainwater is stopped from flowing down at every 300 mm. And once the water stops, it accelerates erosion of wood. If there is a screw there, the water holds the screw and starts leaking. So this is how the construction was prevalent earlier. We were maybe the first ones, but we provided these vertical battens and the purlins are provided above this. So what happens is, even if a Mangalore tile cracks, the rainwater straight from top goes out of the system. for an additional protection to wood, because wood is a very expensive material, and every wood that we use in construction industry, we are cutting a tree, so oxygen is anyways depleting, so we are not doing good for Mother Earth while we use in construction. You can always use artificial wood also in structures which are not. This was a grade 1 heritage building, so this is actually, I can tell you, this is VT station. So this slide, friends, is 25 years old. And trust me, even today, after 25 years, there is no leakage in the sloping roof of VT station, which we restored in 2001. So coming back to the point, in VT station, I had to use wood. But if it's not a so important structure, not a grade 1, grade 2, grade 3 heritage structure, we can always use marine ply also. We can use any other, instead of wood, we can use artificial wood also. It doesn't matter really, because we should all try and reduce the use of wood in construction industry as far as is possible. So let's go to the next type of waterproofing. This is a flat slab. Whether it's a load bearing, the same slide would be there in load bearing also and in RCC frame structures also. In both, we have a flat slab. So I have a question to all of you. What is the exact use of brickbat? And what is the exact use of IPS? And what is IPS? We will see it in the slide next. But just keep this photo in mind, the central photo. This photo shows that he is removing the old IPS with a chisel and hammer. We will be seeing the do's and don'ts of each type of technique. And the third photograph shows the dedicated ponding that is done. Ponding, people also ask a question for how many days you should do ponding. I will say do it for 60 days if time permits. Do it for 28 days if time permits, but not less than that. Concrete, as we have all been taught, the cement rather, achieves 99% strength up to first 28 days. So why not cure it for 28 days? We say, no, the client wants to use it. Coach, nothing doing. Will the doctor give you a discharge if he is not happy with your health after an operation? You might just say, sir, I have to go and attend a meeting. Doctor will say, shut up and lie down. He decides for how many days you have to be in the ICU, for how many days you have to be in the ward or private room or wherever in the hospital. Then also he will say, now you are all right, but go home and again take rest for 15 days. Only after that you go out. Doctor prescribes and most of us follow. While in repairs, we are the doctors. Why not we dictate with the clients and tell them that curing must be done. This particular photograph you have to do for 28 days. It is for his benefit. His structure will not leak. Now let's see why I have put this second photograph. Do you see that most of the joints in this brickwork are very uniform and narrow? These joints are about ½ inch to 1 inch thickness. A bad quality waterproofing has joints of uneven thickness, even 1.5 inches, 2 inches thickness. See, in olden days, they used to use brick bat, the broken brick pieces. But it is good to use even good quality full bricks. Or it is, I would recommend personally to use good quality bricks, full bricks in waterproofing. Because brick bat is a horizontal brick masonry that you are creating. Why we are creating? Let's see it. Now, these are the do's and don'ts of re-waterproofing. Let's first see the do's. Check corrosion damage to top and bottom reinforcement of the slab. See, this is again, though it's in the masonry structures, it can be there because the slab can be RCC in a load-bearing structure. As I mentioned some time back, there is a top reinforcement also in a slab, bent up reinforcement, what we call it. It corrodes. The top reinforcement of beam corrodes. And this corrosion also damages the waterproofing above and stops the structure from being watertight. So first and foremost thing is check if the top reinforcement is corroded. How do you check? By simple cracking. You see whether there are cracks. Now in cracks, again, two things. One is if the cracks are symmetrical or geometric in nature, then these are predominantly because of structural illness. And if the cracks are haphazard, not in a pattern, then these are because of defects in material. So if the cracks are, again, if the cracks are symmetrical and geometric and well formed in a particular direction, two directions, even if it is diagonal, it is a straight pattern of cracking. Like shear cracks are diagonal. You can see multiple shear cracks in a beam, but those are structural cracks because of overloading. Whereas haphazard cracking is because of material failure, fire damage or any other things. Treat the slab for corrosion. If you see these cracks, point number one of those, then treat the slab for corrosion. How? We will see it later. Observe cracks in slab and grout prior to brickbat. This is what I just mentioned. You see the cracks with the naked eye. How do you see the cracks? You will not see the cracks unless you vacuum clean. I'm talking of vacuum cleaning and not blow cleaning. See, once you use a blower, the dust goes into the cracks and it fills up the cracks. Fine cracks I'm talking about. But if you vacuum clean, even the finest cracks is opened out. Uska muh khul jata hai. So you are very clearly able to see. So vacuum cleaning in re-waterproofing projects is extremely important process. Like you go to a doctor or a nurse, she actually cleans up your wound with some kind of insecticide or whatever. Not insecticide. There's something called. There's a word for it. I'm not remembering that. And this is this is some painter painting on the screen. Are you also able to see it, or only I am able to see it? There is
Yes, sir. Some disturbance.
everyone is able to see it, right?
Yeah.
I think that needs to go. So coming to the check slab thickness and adequacy. While you are doing the re-waterproofing, you may have to check the slab thickness, because this is an opportunity. If you want to put an overlay, this is an opportunity. If you put an overlay, the structure lasts very, very long. I have restored a couple of bridges with a structural overlay for more than 20 years. It lasts very, very well if you put a structural overlay. False marks and ample curing by ponting. We just saw of ample curing. You know about false marks. Why false marks are provided? False marks is the marking that we provide on the top of IPS with a nylon rope. Earlier in my olden days, we used to use rassi, coir thread. But nowadays we use nylon rassi, and those false marks have to be at least 3 to 4 mm deep. See, why this is required is in an IPS, we sprinkle dry cement on the top, and that dry cement shrinks. If you want to contain the shrinking, you break the IPS, topmost portion of IPS, which is maybe 3, 4, 5 mm, into small square shapes of 300 by 300. Now, why 300 by 300? Is there a science? No, you can go for 250 by 250 also. You can go for 350 by 350 also. But don't make it too big. Don't make it 1 meter by 1 meter, half a meter, 500 by 500. No. Because smaller the thickness, smaller the dimension of the false mark, better will be the efficiency of this thing. 300 and 300 is ideal. 250 by 250 is also okay. 350 by 350 is also okay. What are the don'ts of re-waterproofing? Do not use crowbar, pickaxe. See, very simple, logical. You want to remove waterproofing. You don't want to break the slab. So if you use crowbar and pickaxe, kudal आणि parai घेऊन जर ठोकायला लागलं, तर the whole thing will crack. Even the impact will damage the crack. See, when you do re-waterproofing, even the RCC slab beneath is not as strong. It is 20-year-old or 25 years old or 30 years old or 40 years old slab. And if it is a load-bearing wall and it's not an RCC slab, it is a jackarch or wooden joists and then brickbat coba on the top. Brickbat in the sense brick concrete on the top. You have to be extra careful while re-waterproofing. Because if you're removing the re-waterproofing, that has been done in cement by somebody. Cement is stronger than the brick masonry slab, a brick lime concrete slab. So you have to remove it very carefully. So high impact tools should be avoided. Stack the material in one. See, once you start doing the re-waterproofing, what contractor does is he gets huge stacks of brick and stores it at one location. That particular slab gets overloaded and it deflects. Can you see this? So in an entire slab, you stagger the bricks that are kept, or the cement that he brings to the site, stagger it so that you don't have a particular slab loaded beyond the load carrying capacity. If it is a residential slab, the load carrying capacity is 200, 250, 300. You segregate the whole thing. And use of high strength cement. See, today we have extremely high strength cement, but waterproofing, plaster, brick masonry are delicate materials. They do not require strength, they require impermeability. Do not require strength in the sense, don't get me too wrong. It is, you don't require the high strength, you require higher impermeability. So do not use high strength cements. If possible, if you are able to get, which nobody is able to get now, use 33 grade cements. With a lot of difficulty, we get 43 grade cements today. But if we only have 53 grade cement, try and mix it with up to 20% fly ash. If fly ash is also not available to you, try and add non-shrink additives in entire waterproofing, entire plaster. It adds to the cost, but it gives you rich dividends. It's extremely good to add non-shrink additives in the entire brick masonry, external plastering, and waterproofing.
So non-shrink polymer gloves are okay for this?
Yes, of course.
Okay, thank you, sir. Thank you.
Yeah. Use a cheapest material, because civil engineering, the industry looks at us for economical options. So we try and use the best. That's why I said fly ash. Fly ash is what? Zero cost. It's a byproduct. It's a waste material actually. So if we use 20%, 25% fly ash, it automatically, see what we are trying to do by addition of fly ash or this, we are trying to curb the shrinkage cracking. Simple. This is the in replastering. Raking is extremely important. See, raking means if this is a brick masonry, and if you do not rake out the joints, how does the new plaster stick to the masonry? Because as soon as you rake out the joints, raking is where you make deep impressions of 5 mm, 7 mm or whatever, so that the new plaster, once you apply, it gets a grip into the masonry. It gets grip every 10 centimeters. See, only a spider can climb a glass because it probably has vacuum. Plaster does not have vacuum cups, no? So how does the plaster stick to the masonry? Only by bonding. But if you do raking, it will also get horizontal seating. Every height of every joint, you will get a seat where the plaster can hold on stronger to the brick masonry. So raking is an extremely important activity before we do replastering. Second aspect is, if you see this brickwork, this photograph has been provided because brick original color is red. This you can see it only here in some portion, The new color is white. Why? Because the original plaster has been removed. But still there is a cement dust which is bonded to the original brickwork. If this dust is not removed with a abrading material, like a wire brush or something, then this dust will act as a debonding layer between the new plaster, because new plaster wants to stick to the brickwork and not this cement layer which is already hardened. See, hardened cement will not easily allow the new cement to bond with it. See, in a plaster, what is bonding? It's a cement which adds to the bond strength, cement water. So this is extremely important to remove in this particular photo, is extremely important to abrade and bring the redness of the stone. So remove that top, whatever, micron layer. This layer must be few micron, maybe 50 micron, 100 micron. Nobody knows. So just remove it with a light wire brush. So abrasion also should not be extremely heavy that the brickwork is damaged. The bricks are damaged, in brick masonry. So let's now another thing why this photograph is here is chiseling. Removing a plaster also is a very important technique. Let us see in replastering the do's and don'ts. These are a few sample photographs. So I don't need to teach water replastering, but I will also talk about why double layer plaster and why single layer plaster inside. We'll talk about it in this thing only. In replastering, what are the don'ts? Check and remove only debonded or poor quality plaster. See, if you go to a doctor and say that, doctor, I got hurt in this portion of my arm, so he will not remove the entire skin, no? He will only treat that portion. So if only some part of the plaster is bad, why do we forcibly remove the entire plaster? So identify if there is a leakage and you must do replastering as part of your techniques of repairs. Then identify the debonded portion. Then go to the last point, use cutters for cutting the brickwork and plaster also. See, we use cutters to identify, make a rectangular or a square pattern little beyond the debonded plaster, little beyond. And only then remove that with a light chisel and hammer. Because since it's debonded, it will come off very easily. If you are trying to remove a strongly bonded plaster, then that plaster will offer huge resistance, and in the process you will damage the brick masonry or the block masonry or whatever that is. So first technique is do not remove plaster that is not debonded. Now the challenge is if you put new plaster, you easily see the patchwork. You see the patchwork because the new plaster is done by a different kadiya. The old plaster 20 years back, 30 years back is done by some other kadiya. So you cannot match the texture of the external plaster. Then it looks bad, it looks patchy. So that's a challenge. Suppose if I get a cut here on my cheek and I get it stitched, I can see it. If I am Salman Khan or a film hero, then I'll go for a plastic surgery or some kind of a cosmetic surgery to hide this. If the structure is that important and the client says, oh, I don't mind paying extra, still do not do replastering. You can go for a thick quality paint, 1 mm thickness paint, and any kind of, heritage paints, or there are extra thick quality paints which can hide all this. This is like a plastic surgery. So you are hiding the difference patchwork. It's much superior to spend on a good quality paint rather than removing the entire plaster forcefully. Is this clear point? Rake out the joints is also very important. We just saw. Check joint strengths. Check the joint strength. How do we check the joint strength? The best part is, see, there is a flat jack technique where, but I don't use it at all. I know about it, but I don't have the equipment because I don't believe we need to go to that level. Simplest is take a small pointed tool and try and rake out with the hand force. Do not use too much of force. If the mortar in the joint is easily coming out, that means the mortar is weak. Now, do we need to replace the whole mortar? We need not. We can replace only the top 1 centimeter or so. Outermost 1 centimeter on both sides. That's it. We need not remove the entire load bearing. If it is a load bearing masonry, in load bearing masonry, friends, there is a huge factor of safety. Huge factor of safety, particularly in old constructions. Huge factor of safety for the kind of load that the structure is expected to take. So let's not worry too much about the strength of the mortar. So this is what I mean by check the joint strength. Pre-wetting of brickwork, you all know, because we don't want the bricks to absorb water from the newly placed plaster. You are teaching that to all the students. If that water is removed and sucked by the brickwork because it was not made wet, then that plaster will not develop strength. Let's not make it too wet also. It should be saturated and surface dry, SSD condition, what we call. The brickwork has to be saturated while we start the replastering, but it has to be dry on the surface. The brickwork is not expected to release water in the new plastering. It is not expected to absorb water from the plaster material. Do not remove good plaster. This is the golden rule of replastering. Do not use heavy hammers for removing. It's not required. It is not required. Doctor uses a small blade, no? He doesn't get a chopper and does operation with it. Why? Then why? Like we said, we have to get to the finalities of understanding our materials and use them. Do microsurgery. It's a time that we learn. I will show you one of the techniques of microsurgery, which we have been using for last almost 15 years. Very effectively, very successfully. Clients are very happy with it. Do not damage the brickwork while replastering. If you while removing the brickwork, while removing the old plaster, you see that the bricks are coming off with it, that means there is something wrong that you are doing. It's not needed. You are removing a plaster that is strongly bonded to the brick masonry. Please do not remove it, and do not increase the thickness of the plaster. A 6-storied building can be easily out by 2-3 inches verticality. Bad quality construction, I'm saying. Good quality construction, it can be out by half inch or whatever in verticality. So if it is out by a couple of inches, how do you not increase the thickness of plaster? You can provide concrete bands at every slab level and break the thickness. If you see old buildings, they used to have a band at every slab level, and that band used to allow you to. Now if I'm trying to show you, these are the limitations of online. If it is on this thing, I could have shown it on the screen also, but here, if this is the upper floor and this is the lower floor, and if there is a band in between which is projecting, then I can shift the lower plaster inside, which nobody will even see. So it's good to have a RCC slight projecting band, 3 inches, 4 inches, 5 inches, so that you can adjust the plaster on every floor. So this is how you can increase. We do not increase the thickness. This is how you can use to contain the thickness. This is the micro grouting that we use. Can you see this photograph? We are grouting a load-bearing masonry brickwork only with these are actually injection syringes. The same injection that is used by medical professionals in giving us the injections. So these are the syringes available with any chemist. Earlier they used to cost 2 rupees. I don't know what is the latest cost. We use the same syringes also, which have a thickness of 0.4 mm. The diameter is 0.4 mm. And what material goes through 0.4 mm? Practically any material goes. But if you use low viscosity epoxy, it flows very, very well. If you see here, you can see so many syringes every 3 inches. We have just first put the needles. Here also you can see it. In this photograph also you can see every 2 to 3 inches. And through every needle, we inject the epoxy. It goes inside, it gets absorbed in the material, and the crack gets filled up properly. Any structure, any wall that has got cracking on both sides, symmetrical cracking on both sides, you can safely presume that these cracks are through cracks. If you replaster, these cracks will reappear, because in replaster you will still have air in it. So you need a material that is strong, which resists the expansion and contraction of the air. So that can be achieved by this micro grouting. We have successfully tried this a few years back. We are using it for almost 12 years now, 12-15 years, very successfully. This can also be used on concrete as soon as you see the first corrosion crack, which is very, very fine, very, very fine, less than half mm. You can use this technique so that you are arresting the corrosion at that very location, at that very level. You are not giving it a solution, but you are arresting it and increasing the life of the structure. I'll have a small case study on this. little later.
How much should be the
Now,
depth of the crack? How much should be the depth of the crack when you go for
it
micro?
will, the needle is only 1.5 to 2 inches.
Fine,
So
sir,
only
fine.
that much depth you go. See, you can see
Okay,
this. The needle is only half inch or 1 inch inside.
okay,
These
okay,
small
okay.
needles, and this is the syringe which is filled up, and you fill every this thing. So it goes only 1.5 inches, which is good enough.
Okay.
It works very effectively and beautifully because it's a epoxy which is as flowing as is water. So even if you inject it, it gets absorbed one into the material and it flows into the crack up to whatever depth it can. It can go, I have not checked actually, but it can easily go to 2 or 3 inches also. So if it's a 15-inch wall or a 18-inch wall, if it is filled up on both sides by 3 inches, the trapped air in between, even if it heats and expands and contracts, it will not have enough expansion and contraction force to put pressure and reappear the crack, make the crack reappear. If we just fill it up on the top, it reappears. Like, see, what mistake they make is they just fill the crack with a painter's putty and paint it, and that crack reappears in less than 3 months' time. It's not a successful repairs.
Thank you, sir.
Yeah, yeah. And sorry, is there something? So I'll
No, sir, I
carry
was
on,
not
right? So
speaking. I was not.
now this is what you see on in this inset photograph here. This is what is called a nipple or a grouting tool. We used it for the first time. Hello. Is there a question? See this. If you see this photograph, you can see a multi-perforated nipple. So this nipple will go inside concrete mega slabs. This slab or this slab will have a thickness of 100 mm, 200 mm, and things like that. Here, what you see is in this side photograph, he's showing grouting in a brick masonry wall also. So we do grouting, cement grouting with non-shrink additives in brick masonry walls, concrete slabs to make them watertight, or anywhere you want to avoid or you want to remove the air from the material and replace it with some construction material, the best technique is to do grouting. And in grouting you can use simple cement with non-shrink additives, you can use polymer, you can use epoxy or any other material, you can use fly ash cement. You can actually play around with your material and the consistency depending on, because in grouting no two cases are similar. How much pressure to use, people ask me, 1 kg, 2 kg. If you are doing vertically, now this guy is doing vertically down, so 1 kg pressure is good enough because 1 kg will anyways get vertically down, is the grout is going towards the gravity. It will also, now this photograph, if you see, this is a very defined crack. So to grout this crack, which was in a 1 meter thick slab, I spoke about this, I think, in my last this thing. So this was a 1 meter thick slab, and on that slab we had to do grouting. So this grouting had to. So that's the reason these are so close to each other. This is only about, I think, 6 inches. The nipple have been driven only 6 inches to each other, and then we put grouting. What this guy is doing, those who do not know grouting, what this guy is doing is this is the tank which has a cement and non-shrink additives solution, and this guy is doing a pressure pump with a foot pressure pump. Cycle la हवा भरायला जो पंप वापरतात, that also can be used. It can easily give you 1 kg pressure. This can give you 2 to 3 kg. Beyond that, if you want to have a pressure of 4 or 5 kg, the grouting techniques will have to be different, because this nipple will uh, come off on its own because of the pressure. It will not be able to sustain that pressure because the bond between the nipple is actually glued to concrete surface. You drill a hole, put this nipple inside up to whatever height you want. You can see, if you want, you can put it up to this or full or whatever. This is the thread, and to the thread we connect the this thing. This is where you see a brass connector. You connect the brass connector to the plastic nipple. The plastic nipple is left there after grouting. You cut the head off. So this is how a grouting technique is. I'm sure you all know about it, but grouting is a very simple yet very complicated system which requires huge amount of experience. You can see this slide in which we are doing grouting in a this slide here. We are doing grouting in a, this is as someone said, this is a polymer grouting being done in a ashlar stone masonry wall. You may say, why are you doing ashlar stone masonry grout? There are voids inside, and these voids, how did we know the voids are there inside? We can use radar. We saw radar which is used for last time, or you can try and use the technique of hammering and listening to the sound. Any void inside can give hollow sound, but this stone masonry in this structure, this right, hello, this stone masonry structure had a stone of 150 thickness. So sound technique will not be very useful. This photograph does not show anything related to grouting, but this is where we had done the jacketing of stone masonry walls using graniting. We will talk about it when we go to the graniting section. You can see the reinforcement that is laid. This is another grouting done in a ashlar stone masonry. This is the same technique which we saw where last time we had used the same structure, where last time we had used the truck jacks to push the masonry back, to the crown stone back into its original position. Do's and don'ts of grouting. Identify the purpose of grouting clearly. Identify why we are grouting. The common agenda of grouting is expel the air and replace it with any construction material, that is cement, sand, or whatever. So identify the purpose, how much we want to do. Identify cracks which are active or passive. Active cracks, even if grouted, they will reappear. Grouting will be successful only in passive cracks. Extent of damage to be studied and marked. We need to clearly identify what is the whole area or which is the whole crack where I have to grout. Select appropriate grouting material or appropriate grouting technique. Appropriate material is we saw cement, sand, polymer, epoxy, cement fly ash, or so many. You have about 8 or 10 different materials that can be grouted. Refusal of grout shall be clearly understood. Refusal of grout means when you put a pressure and the void is filled up, the structure starts refusing further grout and it rebuffs, it gives back the pressure. That is needed to be clearly understood. Many a times it's a false rebuttal or the false refusal from the structure because there is clogging or there is hardening of the material inside while you are grouting. That has to be very clearly. It requires a little experience. And don'ts means grout active cracks. I just saw. If you grout, they will reappear. So it's a wastage of money. Excessive grouting. Avoid excessive grouting. It is like filling up a balloon, no? If you fill it excessively, it will burst. So excessive grouting should be avoided. And excessive pressure also is required to be avoided. Try and understand you are repairing a damaged and sometimes a delicate structure. Anything excessive has to be avoided. This is the structure. Now, if you see this photograph, this is where the original, this also is a load bearing structure, grade 1 heritage building where we provided additional reinforcement and did graniting from both sides. So if this is the wall, we put graniting on both sides and then look at my action again. If this is the wall, we put additional granite from both sides with a pressure. You all know graniting. Graniting is where you are putting cement mortar of a specific grade. You can design granite for M25 grade, M30 grade, M35 grade mortars also. Beyond that is not required also, and I have never done it. So if someone across the world is doing M60 and M70, I'm sure people must be trying that. It's not a rocket science. It's not difficult, but beyond that has not been my requirement of graniting. So this is what you see here is a graniting machine. This thing, which is where this is a tank, and then there is a compressor, with the compressor you put a pressure of 5 kg, 6 kg, 10 kg, 25 kg, and then you put this mortar with a pressure onto the wall that you want to strengthen. So this distance is close to 750 mm or 1 meter. about 3 feet plus, and then you hit the material. This material has to hit. If you see this, the central photo, you can see this material is hitting the surface at 90 degrees. If you do not hit it at 90 degrees, and if you hit the subject at an angle, then what will happen is part of it will be reflected or deflected by the structure, and the wastage will be more. Even in this, there is a wastage. If you can see this portion, this is a wastage. So this wastage cannot be reused inside the machines, because this is already set. So you can't use a set material for a reuse of concrete. And then what this gentleman is doing is he's doing leveling of graniting. Do's and don'ts of graniting. Surface must be firm and clean. Very obvious. Use of pressure jet and air blast. It's a must. You can't do graniting without a jet. If the surface of treatment has high absorption, then it must be kept wet for a time period of 6 hours before. This is like a plaster, no? It's a structural plastering overlay that you are doing. Granite is with mortar. It's not with coarse aggregate. It's like a plaster. So the same thing what we do for brickwork, pre-wet it. It's done for this also. Do not do graniting at an angle. We just saw use refuse material. That the material which has fallen, do not use. This is we just spoke about it. Raking again is the same thing in stone masonry also. If you have now in stone masonry, even if there is no plaster, raking is very important for aesthetic purposes also. And second aspect is raking helps the structure breathe, the masonry breathe. Breathe in the sense stone surface absorbs water, rainwater. The best quality stone, that is basalt or granite, absorb the least quantum of water, but they do absorb. But the more absorbing stones are sandstones, limestones, which are also used predominantly in construction. Then they absorb water, and the water evaporates out from the joints. So that is called breathing. That process is called breathing. So if your joint is stronger than the stone, like if you use cement mortar for joint filling in a sandstone, the sandstone actually starts eroding along the joints in a few years' time because it stops breathing. Cement is stronger. Joint has to be softer than the material of construction. That is, the joint has to be softer than brick. Joint has to be softer than the sandstone. Joint has to be softer than limestone. As far as this masonry you see on the left hand side, it's a sandstone masonry. On the right hand side, what you see is basalt. Basalt is a very, very strong stone. Use cement mortar in basalt, doesn't matter. It doesn't hamper the. Even granite is extremely good. These are igneous rocks, no, which are very, very strong. So nothing happens if you use cement mortar in stone masonry, basalt or granite. But otherwise, for all other stones, I strongly recommend you can use cement inside, but the surface has to be with lime. Top 1 centimeter, 2 centimeters of joint, the horizontal distance has to be with lime in sandstone and limestones. This is pointing. See, this is still not a very good quality pointing. I would say it looks very bad. It looks very ugly. Pointing is good for protecting the joints. That is point number one. And second aspect, it has to look aesthetically good. While we do pointing on ashlar stone masonry, we use masking tapes and do the pointing, because the essence or the prerequisite of pointing is the pointing mortar should not go above the stone. It has to be only of the thickness of the joint. And here the joint thickness is few mm, 3 mm, 4 mm. So if you fill the joint with hand or a finger, it will still be more. It will be 1 centimeter and it will go onto the stone. It will start looking very ugly. So do use brush or scraper while raking or pointing, and pointing shall be at joint only, not on stone. This is what we just do. Do not use mechanical cutters ever, because mechanical cutters cut the stone also. You do not get labor who is expert in using mechanical cutter, and even if he starts using it after a couple of hours, he will be tired. and the cutter will easily go on the stone, and that damage to the stone will be permanently damaged, and you cannot repair it ever. Remove the firm or strong pointing. If the joint mortar is firm, do not remove it so easily. Fiber wrap. We saw about fiber wrap last time, and this is a live example of where a load bearing mud masonry is wrapped. On the right hand side, the photograph that you see is a one sec. Yeah, this. What you see on the right hand side is a load bearing 200-year-old mud masonry using fiber wrap. So let me go a little fast on this. Helifix bars. We saw this case study last time also. This is how the helifix bar is about. Here it is 200 mm, but you get up to 450 mm. This is a spiral stainless steel. You need not necessarily use helifix bars. These bars are drilled. This helifix is a name of a company, and it's a patented product. We can also use stainless steel pins which have knurling. They are also equally effective, and grout. Here you don't need to grout. These are self tapping, and they hold the masonry stone very strongly. So this is very easy to apply and easy to install. This we saw this slide in the last thing also. We saw this slide in the last lecture. This is where we have used it extensively in retrofitting. This was a classic retrofitting case. Stitching. Now, stone masonry, you will get cracks after an earthquake typically. You can do stitching. Like if the shirt tears, what we do is a running stitch. त्याला धावदोरा म्हणतात शुद्ध मराठीत. So we can actually do stitch at every 3 inches, 6 inches, depending on the kind of crack and what is the stitching material. So this is typically a sectional plan of a masonry. This is where the crack is, and this is where you put a 6 mm or 8 mm steel rod, at whatever spacing, 400 mm, 300 mm, 450 mm, and fill this with concrete of M20 grade or M15 grade, whatever, doesn't matter. So this is how stitching also is done. You can see a elevation, sketch elevation. Unfortunately, I don't have good slides, but I will try and find out, because we used to do stitching very, very effectively till few years back. But after helifix bars, because here what happens is the stitches are seen. Nowadays, clients do not want the stitches to be seen. So we try and use the helifix bars or other techniques, using stainless steel pins. See, stainless steel we use if it is around the coastal area where the corrosion is high. But we use mild steel if the corrosion is low. This is where a sill band, a lintel band, a sill band, a roof band, and a plinth band. 4 bands are very essential in load-bearing masonry, concrete bands. Any book can give you in details about this. This is where you can create a lintel band if the lintel is not available. You can put in plan. Actually, you can use, if this is the wall that bends at 90 degrees, you can see a 3D image that is, it is. So this is where you provide a lintel band. If it is not originally provided, using weld mesh and then plaster it or gunite it. So this acts very effectively. Put it on both sides, inside and outside of a structure, for more effectiveness. This is how it goes. RCC structures. Let's go a little fast. Cross section of waterproofing, purpose of. Now this is the cross section of waterproofing. What I wanted to share. It's already 12:20, only 5 minutes more for me. So RCC stone coping is very important for pushing the rainwater outside the structure. So if the parapet wall cracks, RCC stone coping helps. RCC stone coping, not mortar or nor pure concrete, not PCC. There has to be a reinforcement in it so that it does not crack. Internal or external plaster, yes, very important. Rounding of water is very important for the water to flow out. IPS is 38 mm. Why 38 mm? Because 38 mm is 1.5 inches. Done by British people. You can always make it 40 inches or 40 mm, but we still call it 38 mm for whatever reasons. We still have the influence of the slavery that we did to the Brits. So it's okay. And brickbat. The purpose of brickbat is not for waterproofing. It's purely for giving slope. If tomorrow gold bricks are cheaper than brickbat, you can use gold bricks also. It doesn't matter. If there is a material that is available to you cheaper and as strong as is brickbat, use that material. If in some remote corner, if you don't have bricks and you want to use stone, which is cheaper, use stone bats. It doesn't matter. So brickbats, people say no, brickbat is for waterproofing. No, it does not absorb. It does absorb water if the IPS is cracked, but it can get saturated in no time and pass the water through. So brickbat is not for waterproofing, it's purely for giving a slope to waterproofing so that the rainwater flows out of the structure effectively. IPS is the only waterproofing material in the traditional technique of repairs. So first and foremost thing is do a cement slurry. On the bare slab after vacuum cleaning and after the cracks are grouted, do a cement slurry, which is in Mumbai slang we call it rada karaycha, cementचा rada. You make a toothpaste kind of a consistency with cement and non-shrink additives and spread it on the entire thing. That will act like a very strong waterproofing layer. Then you start laying the brickbat. Then IPS. China chips is purely for reflecting the heat and for aesthetic purposes. China chips is generally not a waterproofing material, but yes, it adds to the waterproofing value. So you can use China chips instead of people use China chips instead of IPS. That also is possible, but China chips are not as watertight as is IPS. So it is best to put IPS and then China chips on the top. Parapet water and coping we both saw. Let us go. We saw this. See the beautiful view of good quality brickbat laid. We saw replastering is common in RCC and this also is common. Grouting also we saw. Now polymer or epoxy mortar. What you see here on the right hand side, this photograph is actually idli mixer. We used it about 35 years back for the first time for mixing of mortar, polymer mortar. So polymer mortar used to be mixed with hand and it was not as effective. So we started using it as the first time, changed the blades a bit. This is easily available in the market now. So use this for polymer mortar. You will get more cohesive material and almost 30 to 35% extra compaction when you use this head massager. The head massager which is used in saloon, this was also started by us about 35 years back. Use this will increase the compaction. Otherwise polymer mortar is very sticky. You can't use enough hand force to press the polymer mortar. This is where the reinforcement, see there are several companies, Indian and international, they are giving step by step of how to use their polymer mortar. There some companies will talk 1, 5, 15, some company will have some other 1, 2, 8, any other polymer, cement to polymer to cement to quad sand. See, why use quad sand? We can also use local sand, but local sand has absorption and sometimes it's not clean. So they recommend, see, if you have to use diamond, it's better to use it in gold because if you use it in silver ornament, it may fall. Silver is a softer material. So similarly, if you are using polymer or epoxy, you might as well use quad sand. Though it's costlier, it's better to use quad sand. This is where the bonding material is laid. This slide you saw last time of the jacketing. Let me go a bit faster on this. This is where a complete structure was jacketed for, as I told you last time that this structure was used for additional load carrying capacity in an industrial structure. It was some 3, 4, 5-story structure where all the columns from the foundation to top were grouted. Jacketing we saw, fiber wrap we saw, steel plate fleaching we saw last time. Do's and don'ts of steel plate fleaching is do remove plaster. You must remove plaster. You need to go to the bare concrete slab and then put the steel plate. Grind parent concrete to as much smooth as is possible without causing a damage. do that. Use only through bolts as far as is possible. If not, then you can try and use expansion bolts. Use a plate that is straight and corrosion free. Grout the, not angular, sorry, it's annular space. There will be, whatever that you do, there will still be a gap between the steel plate which is straight, a mechanical straightness, and one is a civil straightness, the beam. There will be still a gap. Fill that annular space with bolts, the bolts between the bolts with epoxy. Check the bonding between parent and jacket concrete using NDT. Yes, with a ultrasonic you are able to check the bond between the old and new. It's very easy. Grout the space between the plate and the parent concrete completely with epoxy. This is very important. This is how jacketing is done. Repairs and retrofitting in RCC structures. These are the, for structural cracking and strengthening, these are the techniques. This is a very simple, you can study this slide even individually. I need not elaborate. Time is, let's see the case study one. This is where, this is again a grade 1 heritage building. This is corporation building, Bombay Municipal Corporation. This cracking is because of the mild steel pin. This is a 150-year-old structure. The mild steel pin corroded. Now, how do I replace this mild steel pin? It is not possible to replace the mild steel pin, because if I have to replace the mild steel pin, I have to remove the entire arch above and the load carrying the structure that is resting on this pillar. It's not possible. So if what instead we do is we drill smaller holes and put capsules which are sacrificial anodes, you know. So there are several companies who are giving this in the market. Those capsules are inserted so that we arrest the cracking, the corrosion at that level and replace. So this is how you can see the same photograph. This is where you replace or grout, micro grouting. This, of course, the photo has repeated, unfortunately. This is the same photograph as is the previous slide. This, the corrected photo is not here, but this is where you can see the, this is how it looked, and this is how where you have done after micro grouting. You cannot actually identify where the material has gone, and this is where you put the power throw. See, you can see these holes, small holes where you put the power throw or the sacrificial anode capsules inside. In second case study, you have buried ends. If you see the left photo, the buried ends of wood are eroded. With an endoscope, you can see eroded ends like this. This is a photograph before. So how we go about it is strengthen with steel plates on both sides with through bolting. This is in plan. This is the jacket. This is the joist which goes inside, and this portion is eroded. So you remove this. Either put a new member and put a steel plate so that the whole section load transfers to the load bearing masonry wall. This is how it is done. You can see the steel plate and the bolts. You can see in a line, you know, you can also see in the next photograph. This technique is used where the wood is eroded in center. You can use it anywhere, in the center anywhere, and you can use it at the ends also. Last technique is 3D analysis is extremely important. Once you do 3D analysis in any retrofitting, you can identify the members which are bad. In this case, we have identified, this is only a sample cases I'm talking about. Therein, the entire structure is safe for retrofitting except for these members. So you can identify and restore only these members, retrofit only these members. You need not blindly retrofit the whole thing. So what you need to do is prepare RCC drawings of the existing structure by physical measurements, by any other technique. Try and find out as what is the maximum level of reinforcement that is available easily with cover meters, and do a regression analysis. This is how the structure is. I'm sure many of you are structural engineers, so I need not elaborate more on this. I think this is the last slide that I had. So thank you very much on this small presentation. If there are any questions, I would love to take them. I think I have exactly taken 1.5 hours, but if permitted, I can take a few questions.
Participant who wants to ask the question to sir, kindly unmute yourself and please ask the question.
So what are the policies for heritage structures nowadays?
Can
Heritage
you can
structure retrofitting.
can you be a little louder? I'm not able to hear you.
Heritage structure retrofitting. What are the policies nowadays of the government?
No, see, policies is a very wide and open-ended question. There are three types. See, every city has a heritage committee. There are no heritage committees in second tier and third tier cities, but there is a heritage committee in Mumbai, there is a heritage committee in Pune, Kolhapur, Mahabaleshwar, Mathiran and places. So that's where government is trying to control. First is they do listing, grade 1. Structures which are of national and international level importance are classified as grade 1. Then is grade 2. Structures which are of state level importance and national importance are grade 2, and grade 3 are structures which are local importance. So grade 3 structures in Mumbai we are allowed to reconstruct but use the similar features. Grade 2 you are not allowed to reconstruct but make certain modifications. Grade 1 you are not allowed to make any modifications in the structure, and any technique of restoration or repairs you do, it should not be glaringly or prominently seen. Like I am wearing specs. If I'm a grade 1 heritage structure, instead of specs, they will ask me to put contact lenses, something similar to that. So do not use specs which are glaringly seen, which are openly seen. This is the broad policy. There are several sub clauses in it.
Thank you.
Hello.
Yeah.
Yeah. So wonderful presentation.
Thank
Very,
you.
very simple and very, the complexities are explained very, very simply.
Thank you.
What are the major limitations of traditional methods in heritage management, especially in structural assessment and documentation? And how does the use of BIM support accurate analysis and decision making while preserving the structures? So I'll put my question in the chat box as well.
The first and foremost challenge is heritage structures are no more taught in last time also I said the same thing, in either architectural college or engineering college. It's only a postgraduate subject. And so in heritage, you do require a material scientist in the team. You do require a structural engineer in the team. Uh, the way heritage is practiced today in the country is very unfortunate. An architect is appointed. Even a postgraduate, I have given guest lectures in the best of institutes today in the country where post graduation is being taught in heritage, and even they are not teaching geology as a subject. So geology is a science of stones, and you are using stones in load bearing masonry structures. So the real challenge is BIM. Yes, you can use, but then we have not yet come over the basic challenges of understanding the material. What is BIM going to use? BIM going to be of any use in a heritage structure today? Most technocrats are unable to identify the root cause of a cracking in a heritage building. If the root cause is settlement, the challenge is at the foundation level, and you start grouting, it's not going to help. You start stitching, it's not going to help. You start using helifix bars, it's not going to help. You have to arrest the settlement first. Now, the challenge is arresting the settlement. In many cases, there is a road abutting, so the corporation does not allow you to excavate. So, in one sec. It's showing me low battery. I do not know why this thing is showing low battery. Can you give me a second? Charging. Why is it showing me low battery? Can you help me? ते बघ त्याचं काही-
हे कनेक्ट नाही केलेलं आहे.
Oh, that's what I was wondering. One second. Yeah. Yes. Now coming back to the challenge of uh, heritage structures being conserved today. So the client does not have enough money. If the client is government, yes, it has enough money, but not enough will. If there is will and money, there is no knowledge. So we prepare estimates which are substantially higher, not required to spend that kind of a money. So the whole proposal goes in a limbo because for want of money, in today, unfortunately, our country has not come over Anna Vastra Nivara, the challenge of Anna Vastra Nivara. So heritage comes after that. So all the forts today are being neglected because there is no enough money. So what the question is, BIM is, of course you can use it on major structures in heritage. If it's a mega project in heritage conservation, of course you can use. Why not? But we have not yet come over the challenge of understanding the structure, knowing construction techniques, which new materials to use, and blend them properly with the old material. We have not come over these challenges as yet.
Yes, thank you. Thank you so much, sir.
So one more question I'm having.
Yeah.
In continuation with what Dr. Madhugandha Mithari ma'am had. So how do you balance structural safety with the philosophy of minimum intervention in conservation?
Very interesting. See, what happens is just the right is the mantra of doing any repairs, whether it's heritage or otherwise. Do just the right. Now, what is just the right? If a client says, I want this structure to last for 50 years after you have restored, then just the right is understanding a material that is not going to degrade substantially in 50 years. If the client says 25 years is good enough for me, then 25 years. If the client says, I want a structure which will last only for 1 year, then leave the client. He is not worthy of being your client. No structure can be restored for less than 25 years of good quality service life. I believe that's been my principle of restoring structures. So go for just the right kind of repairs or replacement or anything. Second technique which I use is like to like material. If there is wood there, use wood. If there is steel there, use steel. If it is uh, limestone of a specific quarry, carry out petrography of that limestone samples, go to that quarry, get the material. If that quarry is closed because the yield is not there, I'd go and find out from surrounding quarries, you will get the stone. So first is just the right, second is like to like material, and as I said also, if it is not a very important structure, like last time I said in Rajwada, though 250 years and an archaeological structure, instead of vaulted brick roof, I went in for RCC slabs. Chakk RCC ची slab टाकली because it was above false ceiling. So that's how you can bring the costs down logically and intelligently, and it is very safely permitted in English heritage techniques also. So this is, have I answered your question?
Yes, sir.
Yes.
Because I can go on and on and on because this subject is so vast, so I would try to be
Yeah.
brief in my responses also.
Yes, sir. Yes. Thank you so much, sir.
Thank you. Pleasure.
And to add this, sir, you will also agree there is acute shortage of contractors who do such type of heritage restoration. Another
That we
challenge.
should, that we should,
I
that
know.
we should, no, that question we should ask Modi ji and Nitin Gadkari ji. They are taking projects at such a fast pace. See, unfortunately, the challenge is, please
Yes,
try and
sir.
understand the challenge. When I took up civil engineering in 1982, in the engineering form, I had filled up first choice civil engineering, second choice civil engineering, third choice civil engineering. So that clerk there saw my form, he says, तुम्हारे बाप का धंधा है? तो I said, yes. तभी तो, वरना कोई civil engineering लेता है क्या? So he said that in 1982, and it had been degrading after that. So today we really have a dearth of civil engineers with 20 years of experience. So many projects have been taken up. See, all the engineers from good engineers either have moved abroad, they have gone into IT, they have gone into finance, they have gone into so many other software developments, but they have not been material scientists in civil engineering, they have not been structural engineers. So आमच्यासारखा गाळ राहिलाय. Those who didn't want to do anything else but civil engineering are in civil engineering. Same is the case with architecture also. I'm not, look, engineering and architecture are parallel professions. So today
Yeah.
there is actually a dearth of civil engineers. And when we as consultants do not get good civil engineers, where is the contractor going to get a good civil engineer? So contracting also has become so challenging today because there is huge competition. So we really have a dearth of good contractors who are quality conscious, do a decent quote, and do a proper job. It's a big challenge. I agree with you.
Thank you,
Training
sir.
is fully missing, boss. Post once they are graduate and they come out, they feel कि चलो गंगा नहा लिया अभी. I don't need to do any reading further. No enhancement of knowledge like this FDP. There has to be enhancement of knowledge for private sector professionals also. You know, it has to be made compulsory, but it's not there.
Thank you, sir.
Thanks. Welcome.
Dear sir, thank you very much for such wonderful session. Your enthusiasm and knowledge sharing session is very useful, sir. And we are happy to listen you for more duration also, and even after this session also, we will be waiting for your session, sir. You are great, sir. Thank you, sir.
Thank you. Thank you. Thank you very much, sir. What I would request is there is a YouTube channel that I have. It's you can type Chetan Raikar and Structwel. Structwel is the name of my organization. You can see it on the screen currently below the logo. So there are. I had done FDP for 24 hours, 8 hours into 3 days for MSBT way back in 2019. Those That's a detailed presentation on restoration, maintenance, retrofitting, NDT, how to identify defects, different types of defects. So you will easily get about 20 hours of presentation in different lectures. Half an hour चे एक lectures आहेत on my this YouTube channel. It is available for everybody. So do go and see those lectures. You may find some of the slides have been copied because these are 325 slides presentation, explained each slide. Today in 1.5 hours I cannot do any justice explaining a slide. The waterproofing, there I have explained waterproofing for half an hour. So you will have all the clear fundamentals. So try and watch that if you are more interested in knowing the subject. It's a detailed presentation. There are so many other case studies also are there. I have a case study of Taj Hotel. I have case study of Wagh Mandir. I think Rajwada also. There are about 5 or 6 case studies also. So please have a look at those presentations or videos. I'm sure you will like them, and they are in Marathi and English. Because at that time also for MSBT there are about 350 total faculty members. And we had done it in Pune, Aurangabad and Nagpur, 3 locations, 24 hours, that is 8 hours into 3 days. So I had conducted that entirely myself, so those videos are there. You can have a look.
Yes, sir. Thank you, sir. Kindly share your email ID also, sir.
Yeah, mine is chetan.raikar at Structwel. Structwel is the name of the company.com. Chetan.raikar at Structwel.com.
Thank you, sir.
Thank you. Welcome.
Any other participant who wants to give a live feedback? Okay, sir. On the
Thank you.
behalf of organizing committee of this AICTE Atal Faculty Development Program, I, Rajguru Kamble, Assistant Professor at Civil Engineering Department, Dr. Davlatrao Ahir College of Engineering, Karad, would like to express my sincere gratitude to Engineer Chetan Raikar sir for delivering insightful and enriching session. Sir, your in-depth knowledge, vast professional experience, and clear explanation of the concepts provided the participant with the valuable understanding of the practical approaches in the structural repair, retrofitting, and the rehabilitation. The real-world case studies and the example shared during the session greatly enhanced the learning experience and were highly appreciated by all the participants. Your guidance on assessing existing structures and improving their resilience has offered a meaningful takeaways for faculty members, researchers, and the practitioner engineers. The session was informative, well structured, and strongly aligned with the objectives of the AICTE Atal FDP. Along with it, I would like to share a thank you to all the participants for their active involvement, keen interest, and the interactions throughout the session. Your participation contributed significantly to the success of this session. Once again, we express our heartfelt thank you to Engineer Chetan Raikar sir for sharing his valuable time, expertise, and the experience with us. And thanks to all the participants for making the session successful. Thank you so much, sir.
Thank you. Thank you very much for inviting me here. See
Thank
you,
you.
see you
Thank you.
soon. Bye bye.
Bye.
I have given my mobile number also and the mail address also. So do keep in touch. Thank you. Bye bye.
Thank you. Thank you. Thank you so much, sir.